Hello again. Today we're going to be learning about creating flowchart proofs. Before we do that though, it would be a really good idea to remind ourselves about two-column proofs. It's actually going to help us with a flowchart proof too. So we're going to do this problem here as a two-column proof. I would highly encourage you to pause the video and try it yourself, but I'm definitely going to start it now. So again, with a two-column proof, you say whatever you know on the left side of the column and the reason you know it on the right. One of the things I know for sure is I know PR is equal to TR. I know that because it was given right here to be true. So that was given to be true. That's how I know it. Whenever I write something on my proof, that's when I mark it on my picture so that I can start figuring out the rest of it. So I know PR and TR are the same, so I'm going to mark those congruent right there. I also know IR is equal to AR right there, because that was also given, right? So there's always some information that's given. And so I always list that first because it's easy to make sure I get that. Again, once I list it, I like putting it on the picture. There's AR and IR being shown congruent. All right, I want to prove that PI and AT are the same. So I want to prove that these sides are the same. In order to do that, I'm going to have to prove that the two triangles are congruent. I'm going to have to prove that those triangles are congruent. So I'm going to need a way to do it. So far, I've got a pair of sides here and a pair of sides there. I need one more thing. In this case, it'd be those angles there, because those are vertical angles and vertical angles are congruent. So that's what I'm going to write. I know this angle PRI, is going to equal this angle TRA. And I know they're congruent because they're vertical angles. So my reason is vertical angles. When we have vertical angles, the angles are congruent. All right, now I've got these triangles congruent because I've got that side and then an angle and then a side. So I'm going to state that next. Triangle, let's see, I'm going to say PRI in that order. It doesn't really matter the first one, PRI. What does matter is that I make the second one in the same order. If I go P to R to I, that's following along this one tick mark and then the two tick mark. So in the triangle on the right, that would be the same as TRA. So triangle TRA. And I know that's true by my side angle side shortcut. Right, I had a side, I had an angle, I had a side angle, side. All right, I'm not done. I always have to finish up with what I'm trying to prove. Now that I know the triangles are congruent, I definitely know PI is going to be equal to AT. I know that because when I've got two triangles are congruent, all of their parts are congruent, including those parts. We had a shortcut for that we learned the last time. And if you remember that shortcut, it makes it a lot faster. If you don't remember it, you can write, because when triangles are congruent, all of their parts are congruent. That just gets long. The shortcut for that was CPCTC, which again stands for corresponding parts of congruent triangles are congruent. All right. Okay, now that we've done that, we're going to learn a new type of proof. We're going to learn a type of proof called a flowchart proof. Now, a flowchart proof is very, very similar. You still have to state what you know and state why you know it. It's just the order is going to be different. With flowchart proofs, you put what you know into boxes. And then the reasons you know it, you're going to put that reasons below each box. So instead of having them in columns, what you know on one side and how you know it on the other, what you know is going to be in boxes, and the reason is going to be right under the box. So what we're going to do first is we're going to do this same exact proof we just did, but now we're going to do it again in flowchart form. So here we have the outline of what the flowchart proof is going to look like. Please note, not all flowchart proofs are going to have this exact same order. This particular one does. what we're going to do is we're going to take all of the reasons and all the things we know and the reasons we knew them. They're all jumbled up. They're the same things we had earlier. They're just jumbled up. And we're going to put them into the appropriate box. I realize that my video might be up here in the corner, so you might not be able to see all these. So I'm going to get rid of these instructions. And I'm going to drag all of these down here so we can see them. All right, so those are all the things we knew and all the reasons we knew it from the previous proof, but they're all jumbled up. So let's see if we can list things. One of the first things we listed was our givens, PR and TR. All right, I'm going to put that right here. And I knew that was true because it was a given, so I'm going to put that here. I also knew that these IR and AR, I knew they were the same, so I'm going to put that here. And that was given. And the third thing I had said in our previous proof was I had said that these angles there were congruent, which are these angles. And do you guys remember which of these reasons was for that? Hopefully. It's because they're vertical angles. All right, here's the crux of a flowchart and why it works. Now that I listed these three things, that side, that angle, and that side, I can say the triangles are congruent. So the triangles are congruent by side, angle, side. The way a flowchart works is it shows these three things coming together to prove the triangles are congruent, right? I couldn't have proved these are congruent without that side, those angles, and those sides, right? That side, angle, side shortcut, all three of these came together to prove that. If this one was missing, right, I would have just a side and a side. That's not enough. I need at least three parts to show a triangular congruence. So here are my three parts. And then the flowchart kind of connects them all up and they flow into this conclusion, right? And then because I knew those triangles were congruent, I know that my PI and my AT were congruent. I knew these ones were congruent. And the reason for that was CPCTC. Corresponding parts of congruent triangles are congruent. Same proof as before, right? Same givens, same reasons. The only difference is the order they're put in. These three were all put on the left and they flowed into those triangles because I needed these three to state that the triangles are congruent. And then that flowed into the next conclusion because I needed to know that the triangles are congruent in order to say that PI and AT were the same length. All right, we're going to try a few more of these. The next one is just blank, and we're going to do this one together. All right, let's get this one started. Same thing as a two-column proof. I normally start my proof with the things I was given. So I'm given that KI and TI are equal, so I might as well write that. The difference is I'm going to be putting that in a box this time. So KI is equal to TI. That's something I know, so I put it in a box. And under that box, I write why I know it's true. I know it's true because it was given. Same thing as in a normal proof. After I write that, I like to mark it true on here, KI and TI, because it's going to help me to kind of figure out how I'm going to prove that these triangles are congruent. All right. The other thing I know is IE bisects angle KIT. That's a word we might not have heard of for a while. Bisects means cut in half, but that's something I know, so I'm going to write it here. IE bisects angle KIT. And I knew that because it was given. Now, what does that tell me about the picture, right? If this IE bisects that angle, that means it cuts the angle in half. And if it cuts the angle in half, that means these two angles here are equal. So I actually know those angles are equal. Now in my picture, I'm going to just name this angle 1 and angle 2. And that's something else I know. I know angle 1 and angle 2 are equal. So that's what I'm going to write next. I'm going to write it right here. Angle 1 is equal to angle 2. And I'm putting it right there for a very particular reason. How did we know angle 1 was equal to angle 2? Well, I knew it because this was an angle bisector, right? Because IE bisected that angle, that made these angles equal. So because of this one, I knew that was true. So this one on the left is going to be connected straight to that, right? This one flows into that one. So that's how flowchart proofs, because it tells you, because I knew this thing, that's why then I know that. I do need a reason under here, right? I need to always give my reason. So the reason I know this is true is because that's what an angle bisector does. It cuts an angle in half. So I'm just going to write definition of bisect. An angle bisector, bisect means cut in half. So anything you want to put there that is fine, just make sure you put something there saying, yeah, I understand because we had a bisector, that made those angles equal. Definition of bisect is probably just the fastest way to do it. Saying, hey, that's what bisect means. By definition, that means it cuts something in half. All right, let's look at my picture now and see how I'm going to prove that these triangles are congruent. Well, I've got a couple of sides, so there's a side. I've got a couple of angles congruent. I need one more thing, and it looks like if I can use that side, that would be my third one. That I think I can prove these triangles are congruent by side, angle, side, right? They're gonna have that side, they're gonna have these pink angles, and they share that third side. So I need to list that third side in my proof. So this one is going to be congruent to itself. Now I didn't need to know anything to know it's congruent to itself, so I'm going to put it down here. IE is equal to IE. Those little line segments over the top. I didn't do it with KI and IT. I probably should. There we go. Why do I know that it's congruent to itself? You guys might remember one way we could say it is to say same segment. Same segment, right? Obviously, any segment is going to be equal to itself. The fancy word for that again was reflexive property. If you'd prefer reflexive property, I'm going to leave it same segment this time. It doesn't matter. But now that I wrote that, I'm going to mark it my picture. And now I can see in my picture, I've got enough to say the triangles are congruent. I've got the sides marked. I've got the angles marked. I've got that third side marked. I've got it by side, angle, side. I'm going to draw that right over here. Triangle, KIE, is congruent to triangle, PIE. Put that in a box. How did I know it was true? By side, angle, side. And now let's remember how the flowchart works. I needed to know the sides were congruent, the middle angle is congruent, and the third side was congruent in order to say this. So all three of those are going to have to point to this box. Here's the first pair of sides. Here's the angle. Here's the second pair of sides. So all three of those are going to connect. So we got side, angle, side. There's my proof. Done. All right, let's do one more, and then we'll probably practice some in class today. All right, so we're going to do this flowchart proof. It looks like it's a pretty long flowchart proof, but luckily it looks like a lot of the things have already been filled in for us. We just need to fill in the missing information. So let's start right here. There should be something there. Again, that is the reason I know this is true. So why do I know AE is perpendicular to SM? Well, that was one of my givens. Remember in a two-column proof, we normally list our givens first? Same for a flowchart proof. I know that's true because it was given. What do you think is going to go there? Yep, my other given. AE bisects SM. So AE bisects SM. All right, this one flowed into that one. So this told me something about that. So let's take a look here. Well, it said AE and SM were perpendicular. If AE and SM were perpendicular, that means these angles, they're going to be 90 because that's the definition of perpendicular. Perpendicular lines make 90-degree angles. So I know that those two angles are 90, right? This one and this one are 90. So angle, I'm going to name them angle 1 and angle 2, just to make it easier for me. And I can fit it in there. So we're going to call this angle 1 and angle 2. So angle 1 is equal to angle 2, which is equal to 90. By definition of perpendicular angles are equal to each other, then equal to 90. They're both equal to 90. All right. Let's see here. AE bisects SM. That flowed into this. SE equal to EM. Well, yep, so then I'm going to mark that true in my picture. SE and EM, but then I need the reason here. So I knew SE and EM were equal because we had a bisector, and a bisector again cuts things in half, cuts things equally in half. So that's the same thing I had before. That's the definition of bisect. Bisect means you cut something exactly in half. All right, let's see what else I've got here. Oh, I've got some reason being a same segment. If I look at my picture, I'm probably going to be trying to make those triangles are congruent. Yeah, I can see which segment's going to be the same. It's going to be that one right there, right? So I know AE is equal to AE because it's the same segment. And now I can say the triangles are congruent. And again, underneath, I got to put my reason. So we'll take a look at that picture. How do you know the triangles are congruent? Well, it's because I've got an angle, and sorry, a side, and then an angle, and then a side that are all equal to each other, right? So, and that it's listed here. There's the angle, there's a side, there's another side. But the order is side, angle, side. So these are congruent by side, angle, side. All right, let's see what that said. Because the triangles are congruent, I knew this, right? Because it showed it flowing into it right there. So SA and AM, that's these ones. That makes sense because if triangles are congruent, all their parts are congruent. I need the reason for that. So underneath there, I'm going to put CPCTC. That was our shortcut for saying if triangles are congruent, all their parts are congruent. And then the very last thing, what always goes in the end? What you're trying to prove. Triangle SAM is isosceles. Triangle SAM is isosceles. How did I know that was true? Well, that's a definition of isosceles. Isosceles is a triangle with two sides that were the same. And we just said that these sides here were the same, right? If I know that those sides are the same, then the triangle SAM is going to be isosceles because that's by definition, an isosceles triangle has two sides that are the same length. All right. That is it for the lesson. There is a worksheet, 4.4.2, Flowchart Proofs. We'll probably be doing at least a start of it in class, and then you'll probably be finishing it on your own. I will see you guys later.